Assalamu alaikum. We are 40 minutes late. So if my colleagues, esteemed colleagues in the panel come, Dr. Mohammed Kurdi, Dr. Mohammed Al-Hijji, and Dr. Umar Al-Tamimi. If you're here, please come up. So this session is all about OCT. Before we start, whoever is left, how many of you use OCT in your cath lab? Okay, so not everybody. Okay, this is a recorded case, and then Dr. Ueki is going to join us live after the recorded case.
I'm Yasushi Ueki from Shinshu University, Nagano, Japan. And thank you for having me, and it's my great pleasure to join this meeting. Today, I would like to share my cases with OCT-guided PCI for calcified regions. So first, pre-PCI plaque assessment is clinically important because plaque type may impact on PCI strategy, especially in case of repeat and calcified plaque. So intracoronary imaging is useful to evaluate the severity of calcified regions. As you all know, calcified plaque can be visualized differently by IVUS and OCT due to the acoustic shadow by IVUS. So currently, only OCT can measure calcium thickness. So why is the measurement of calcium thickness important? So previously, optimal cutoff value of calcium thickness for crack formation, which is very important predictor for stent expansion, has been 0.67 millimeter has been reported. So in other words, if we find severe calcified plaque with calcium thickness more than this cutoff value, we should consider debulking device. So similarly, OCT calcium score based on calcium angle and calcium thickness and calcium length has been reported. And score 4 is a significant predictor for stent under expansion. So let me share the first case. Angiography showed diffuse stenosis with severe calcification in the LED, and OCT showed very diffuse, thick, and concentric calcified plaque, almost all regions in the LED. So at proximal part, so there is a it's coming. So there's the old stent, and in the proximal part of this LED. So as pre-OCT showed severe calcified plaque, so now we can see the calcium thickness. So at point A, it's more than 500 micrometer, and at point B, it's more it's thicker, so 900 micrometer. So based on these findings, rotoablation with 1.75 millimeter bar was performed. And at point B, we can see the significant effect of rotoablation and some lumen gain. So actually, calcium thickness was decreased from 900 micrometer to 600 micrometer with some lumen gain, but almost no effect at point A. And after high pressure balloon dilatation, so there were two cracks at the thin parts at point B, but again, almost no effect at point A. So even after high pressure ballooning, after stenting, severe indentation remained at point A. So then rotablasion with 1.75 mm burr was again performed. Then we can see the lower half of the stent has been removed or cut by rotablasion. Then after high pressure ballooning with bigger size, good expansion was achieved, and these were confirmed by OCT. So second case was 83 years old male with stable angina. So the stent was implanted just 1 month ago, and in the left main ostium, and the target of this session was mid-LED. So this is angiography of the left coronary artery. FFR was 0.77 with step up at the mid-LED. As you can see here, so we can see the very severe and concentric calcification at the mid-LED. So this is baseline OCT imaging. As you can see here, so there's a very thick and concentric calcification in the lesion. And this is a summary of baseline OCT findings. Despite mid-LED, the vessel is very small, and the distal lumen diameter was only 2 mm due to diffuse atherosclerosis. At the MRA frame, the calcium was truly concentric without any gaps. So maximum thickness of calcification was 1.3 mm, and minimum thickness was 0.4 mm. And longitudinal length of the calcified plaque was 8 mm. So these findings suggest to use debulking device such as rotablasion. However, so we consider the stent in the left main ostium, and we also expected some crack and dissection formation at the thinnest part of the calcium. So we decided not to use rotablation first. So we predilated with NSE of 2.25 millimeters. So at first attempt, so we can see some remaining indentation. But after several balloonings, so the indentation so the balloon was expanded without relevant indentation. So this pullback is after predilatation with NEC. As you can see here, so we can see major dissection. A little bit go back. So at this part, we can see major dissection, and then another small crack at the thinnest part of the calcification. But as expected, no effect at the part of the thick part. Then going to proximal. So there's also a major dissection at the fibrous plaque. So after predilatation, we made a major crack and dissection at the thinnest part of the concentric calcium. And at proximal part, there is dissection within fibrous plaque. So based on these findings, we expected that the stent would be expanded adequately. So according to these measurements, stent diameter of 2.25 millimeter and length of 18 was selected. And stent was not expanded perfectly, but after post-dilatation with high-pressure non-compliant balloon, so no indentation remained. After post-dilatation, stent expansion was 100%, almost 100% at both distal and proximal half of the stent. And there were no dissection at the stent, distal and proximal edge, and apposition was seems good. So this is a final angiography. So stent looks very acceptable. So for this case, we performed a follow-up angiography at 1 year and confirmed there's likely no restenosis at the stented segment. So this is my final slide. So in summary, OCT guidance is very useful, especially for calcified regions, because OCT enables to provide detailed calcium measurements, including sequence, and accurately predicts the acute balloon effect as stent expansion, and inform operators whether developing devices are needed. Thank you very much.
Thank you. Very nice cases. Dr. Muhannad, any comments?
No, I think this just shows the importance of intravascular imaging. I have to say that I don't spend too much time measuring the thickness and the length. It just gives you an idea, a ballpark. Once you've done quite a few of these, I suppose spending the time measuring whether it's 900 microgram or 600 micrometer, it doesn't make too much difference. And we have to remember this is a high resolution. Even the slightest of movement of your cursor might not be or give you a different number. But I think, again, this shows the importance of intravascular imaging to plan your procedure and execute it and make sure that you delivered it very, very well.
Okay. Dr.
I totally agree. I think whatever modality of intravascular imaging that you're comfortable with, you should go ahead and use it. OCT or IVUS, OCT give you more laminated lumen in a nice way and show you more details. But if you are very comfortable with your IVUS as well, it's even a tool that they can use. We tend to go into more details. Sometimes it is useful, but sometimes actually taking more time, as Dr. Muhannad said.
Yeah. One thing I noticed, after every step, they repeat, maybe for educational purposes, but
it's academic.
Yeah.
I think that's very important. It's very important to show, as Dr. Ueki showed, is that the response to the debulking or fracturing techniques that you are doing, so you will end up having a really expanded stent or not, so you will understand that, or you will understand if you need additional steps to be done. So it's very important to do it in a stepwise manner.
Very good.